Thank you. So at Enthought, we do a lot of work with companies where they're building some kind of engineering and science app, and or actually many of the times they've already built a scientific or engineering app. And now they're working with the idea of, hey, we have this application that people use, but now we want them to be able to extend it and do other things. And so this is a constant theme. We've seen it dozens of times over the last 15 years, and really have seen almost a dozen or dozens of variations of how you end up handling it and that sort of thing. So what I'm going to do is try to give you a few ideas about the patterns that you see and what the trade-offs there are, and hopefully at the end have some time to demo at least one of the ideas. All right? So there are a number of different starting points when somebody comes to you, and it probably, hopefully, you will see your application in one of these. There are probably other variations, certainly, but if you have a legacy app, then it probably looks like one of these. And so one of the starting points, and frankly one of my favorite starting points, is this specific one. And that is where you have some physics simulator, does data analysis, whatever it may be. The code's written in C++, Fortran, C, something like that. And it really takes text input and creates text output. And that is the engine for huge amounts of science on these things, right? Another starting point is this one, and that is there is this fundamental engine, very much like what I just said, but there's a user interface that's been built that sits on top of that. And sometimes that user interface is separate from the computational engine, and sometimes it's actually embedded in the UI. So it could be separate processes, it could be a single process. And then the third thing that we see is actually Excel sitting over here. And in fact, that is the user interface for these applications that maybe is coupled with, a lot of times what people will do is they'll get ambitious and they'll try to build a UI, and it will build out a lot of the functionality they want, but when they start looking at users have a whole lot of spreadsheets that they keep a lot of information in, and they start wanting to drive from that spreadsheet over to the application or perhaps generate the input files directly from that. So all three of these scenarios show up. And of course, you could replace this user interface on the desktop with a web interface, and we're starting to do that for people. But what I'm talking about here is really what we see as legacy. And so, in fact, the typical kind of situation here is these things are niche solutions. We are often looking at, or we look at software as things like MATLAB and Excel or LabVIEW or Word, and you look at the footprints for these things, and there are millions of people on some of these. Easily, they're going to be hundreds of thousands on each of them. In this world, often the user base is tens, maybe thousands. But at the same time, the codes have been very important to those tens or thousands of people for the last decade or two or three. These simulators have been around a long time. And in fact, even you can't really gauge the value of the software by the user base. There have been millions of dollars invested. All you have to do is think about how many people can do the thing that you do, how many people care about the thing that you do, and what is your salary? Multiply that by some factor of overhead, and then how many of you did it take to build that software? And you start seeing the value of this software. We think often about licenses, and we get mad about MATLAB being 10K or whatever it is to purchase a seat. But if you look at these applications, often the seat licenses, I was talking yesterday at one of the tables, they're 100K. In fact, we have one that if you buy the full suite, it's $1 million. And a single seat is $180,000. In fact, there is a whole world out there where this is the software price. And the reason is they have these small user bases, and you have to recover that expensive salary of all the people like you guys to fill those. So These things have a ton invested in them, but now they have a small development team, or maybe it could range up. 15 is not a small team, but that team is often doing the maintenance. They're managing it. They're doing the analysis of what new features need to come in, and they're doing development. And just like your code, there's a lot of technical debt, right? I mean, there's a whole lot built up over these years that they have to deal with. And because of that, they've moved very small changes over time. But there is this steady revenue coming in for these guys. On the user-based side, their big deal is they're using these codes. They could care less about software engineering. What they care about is solving their problem, whether that is flying an airplane, whether that is looking at satellite imagery, whether that is drilling an oil well, right? And so they're like, give me the software and don't break it. I would rather not have an update than get a new feature if you're going to break my existing workflow, because my money comes in from the oil. So they may want flexibility, but they want stability as well. And so you have these very slow cycles, especially with that technical debt built up. Well, this is the starting place. The goal often is companies come in and say, okay, that's where we are, but we really like Python. We really want to be able to script these applications. The big deal for us is getting end users have a capability they want. Instead of having to wait a year for the next version, can we get something? Can we build it ourselves? Can we automate something that we have to click a button 1,000 times for? That seems simple. We ought to be able to automate that. We'd rather have some enhanced plotting options here. A big one, a huge one, is macro recording. People want to do macro recording so that they can automate those things. Turns out that's really hard on an existing app to add in. And then the other thing is a lot of these companies, they actually have application engineers. They want those guys to be able to build new features very quickly for a customer and show them to them. And then the development team themselves hates the fact that they have very small incremental change in a year. Maybe they could add things faster through this mechanism. So that's the idea. All right. So I guess this is a little bit like dessert. I'm going to eat dessert first, right? I'm going to tell you the way I wish we could do it every time. I'm going to show you my favorite thing, and then I'm going to go and show you, the real world of what happens. But if you have an application that looks like this, where you just have a scripting engine, no UI, no nothing, and you have a willing customer that's ready to go, you can do a whole hour on the different ways of interfacing with this. But the one that we love to do is to pull that physics engine that we just had here, strip out all the glue code around these guys, pull out the physics engine. The numeric algorithms probably come from NumPy and SciPy. You might have some data structures you build in here, file format readers, visualization. All of these modules often come from libraries you have, maybe from the code, maybe from Python itself. And we layer a Python scripting API on top of this. There's probably the need for some C++ and Python wrapping to sit on top of that. And all of a sudden you have this interactive scripting UI. You've really taken, I think about it as pulling the main out of applications and making Python the main. And you have access to everything because Python is everything in this. So you can interact with it at a command line, or you can build a UI application on top of it. All right? So that's kind of the really nice scenario. And the other awesome thing about this is you can now start layering web applications on top of this as well. They have a different flavor often than what you do over here, but it's a very typical addition. All right, so if you don't have a UI, that's where you are. When people have a UI, imagine you have a user interface. The code could either be embedded in the application or not as far as the simulator. People see the UI, but there's actually a software model behind this. And there's view models that deal with what the UI looks like, and there's data and algorithm models. And really, you probably ought to separate these out. But data models that represent how data is stored, and then algorithm models that do your computation. So when somebody has a UI, you would love to be able to rip out their UI, get rid of it, and put in a new one. You don't do that with decades of work oftentimes. They don't have the budget. So these are often written in C#, Java, maybe C++ if you're lucky. If they're in C# or one of those, then the fusing to Python turns out to take some effort. We've gone through that effort many times, so we're used to it now. But there is an impedance mismatch that you have to deal with. And the fast path here is what I call peephole scripting. Or, well, I didn't know what to call it, so there may be a better name. But the idea here is you want, instead of exposing your entire application like I did before to Python, you really take some of these data models and expose them to some ad hoc script. And there are multiple ways of doing this. One common way of doing this is through external scripts. So if we look at this model, this is really, the big deal here is it's minimally invasive. The idea is you probably have a directory of scripts someplace, or something equivalent to that, someplace where they register. And then you have menu items in your application, drop down, and you can select between these scripts. It's a very kind of, perhaps as a Python developer, it's an unsatisfying approach to things, but it's a very pragmatic approach to things because data is exchanged through files, your Python script runs external to your application, and this proves to be minimally invasive, especially if you have a Java or C# application. All right? So that's a huge win. There's very little work on the other side to do. Well, it appears that way, let me say that. The other thing is it's not just Python. If you build this infrastructure, you can support any language. The drawbacks are it's really kind of a glorified batch model on things. And you know, the speed of this is sometimes questionable. If you have large data in your application, you have to write it into a file, call over, read it in from the file, write it out to a file again, read it back in here. That transition can take up a huge amount of time and maybe is not memory efficient on your system. It's not memory efficient on your system. And the next one is actually a big deal. And that is that you don't have any control of the user interface, or not in a sanctioned way, I guess would be the way to say that. But it really is hard to modify the model here because you're really just pulling out these algorithm and data pieces. All right, and then the next few pieces are kind of that hidden baggage that shows up. It turns out that it's not always as easy to manage sub-processes as you think. That's a lot of work to deal with the error handling there. If your scripts break, how to report those to users. All of a sudden, new stuff starts showing up in your user interface to deal with that. And now you have the deployment problem with your application of now they either have to have Python, you have to deploy Python with it, it has to be the right version, the right libraries have to be there. There's work there, all right? This is kind of the fastest way to get there. The next way to get there is has some benefits, and that is really the same thing, except instead of executing as an external application, you put it in Python. So you embed a Python or an engine inside of your code. And then you can, again, have this directory of scripts and functions and have menus to get to those. All right? This is a little more invasive, or a lot more invasive into your Java or C#. We have multiple customers that do it, but there's work there to get the CLR or the Java runtime to work well with the Python library, or with the Python engine in there as well. And you now have, instead of just having clean files that are going back and forth, you're having to tie the memory data structures potentially across these guys. And if you want to get the big win of shared memory that reduces your footprint, you really you can't just marshal the data back and forth. You have to actually figure out how those data structures overlap. So it isn't a glorified batch process in this situation. It's actually, it's better than that. You know, you can have true interactivity where you click on something and instead of having to spawn another process, you can have an immediate computation, which is really nice. But we're still at this point, oftentimes, because of what we chose to do here, of not having, you only have access to a few of the data structures. And when that happens, you don't have access to that, you don't have access to, dadgummit, to the user interface. And it turns out you often want to, whenever you do scripting, it's very nice to do this peephole notion in many places, but many times you really want to get to the UI and be able to modify it. If you run an algorithm, you want to pop up a new window, view your mesh and spin it in a certain direction or whatever it may be. And this peephole approach doesn't allow you to do that in a sanctioned way. We actually have several applications where the UI the customer had was controlled by XML. And so we would change the XML under the covers on the fly actually and refresh the screens that way. But you're really reaching around the edge of the application to be able to do that. It is powerful though to be able to do this, and this happens to be a Python app. Let me see if I can. This happens to be a Python app that we're looking at here, but it demonstrates kind of the power of this idea. And that is, we're zooming in on a region here. We have a huge amount of data here. We're zooming in on a small region, and then that region is being displayed here. And now what we've done is we've provided a location for somebody to write a script, and it's a really simple script. It's actually all just NumPy type things doing a power spectral density estimator here. And so it's doing a calculation on whatever data is in this, and then the output of this is being shown right here. So you could do this in a C# or Java application as well with an embedded Python very nicely. The idea is you just have to take the data from this specific model, make it available in a namespace, run this script whenever this changes, and the update here gives you your results. All right? If we have time, I'll show that in another application as well. So I like that model really well, but very quickly what happens is this set of questions. Hey, this is great. We love that we're able to script now, but you know what? When we're writing these scripts, I only have access to this data, maybe what was in that region of interest, but to do my calculation, I need to do a global calculation across all data, or I need to go into the database and grab 3 other things and have those accessible. So how do I do that? And the answer is, well, you start having to expose more and more and more of your C# Java infrastructure into Python, and it just grows and grows and grows, or you don't have that functionality. So that's the first thing that you run into. The second thing that you run into is what I mentioned earlier. You don't have access to the view models. And so once you've run this script, to be able to go and create a user interface around that, you just don't have that capability. So you pay a price for this, but it's cheaper than doing the full example, all right, or doing a full wrap. Okay, so you know, so we've seen this process so much that this is actually Canopy, you know, as a MATLAB-like data analysis environment, but it's actually built to support this sort of application. And so we built it in a way and architected it so that if you have a C# or a C++ or a Java application and you need scripting capability, then Canopy provides your editor. You can debug from it into your application. You can deploy. It manages your Python for you. And there are even tools there that we have to embed a kernel in C# or Java so that you could call that and access that from the Canopy side. So there's this whole infrastructure here that's built around being able to do peephole scripting, but it also is built to support this kind of application that I was talking about before. And in fact, what we found is Canopy really, or what we designed it as, is really a platform that you can do deployment, you can do analysis, you can integrate training on it, but then you can build domain-specific applications on top of this. And in fact, you can build industry layers on top of it for specific industries, and then proprietary tools on top of that. So just as an example, I'm going to have a few minutes here. I'll try to get to showing some of this in this Canopy Geo application that we have. That's a layer on top of Canopy for scripting in the geophysics world. So Canopy provides all that kind of application level stuff, and then Canopy Geo sits on top of this layer that we have, where you can define your own data structures, or we define a set of data structures actually for managing all the things you might see in geosciences. And then we have adapter patterns for allowing you to read in files and write out to displays. And in fact, if you pull out the geoscience data structures here and put in power plant or chemical plant or airplane in the middle of that, then the same patterns actually work. In this world, we have things like wells and horizons, seismic volumes, all of these different things. You have many different file formats. You plug those in through a plug-in architecture. Those get read into these data structures, and then we have a number of displays that you can use with these. All right? So let me just pull up as quickly as I can here an example of the sorts of things you can do that are interesting or different, I guess. So I'll just pull in a few different file formats. So the adapter, when I drag and drop here, that adapts to the data structures internally to this. And if you have a different file format, you just add an adapter for that file format. You drag it in, and it's available to you. If you want to go and grab some wells down here, we have a set of wells. I drag and drop those over here. And they'll show up in a second as we go and read all of those in. We need to go and add a depth time model. Some of these are in depth and some are in time. So now those will display alongside those horizons. And then let me just go and grab a 2D segment here because it shows off one other capability here. So we're looking at a seismic data set. And so far, it looks very much like a typical application that you might have for geoscientists. But there's a big difference down here, and you might have noticed an IPython shell. And that is, if I come down here and grab this seismic line, I can just drag and drop it. So anything that I see in this user interface is also available, and its full model is available at the scripting command line. So I could go, and in fact, let's see if I have, I could say, listen, from that traverse, I want to go and grab the 100 traits out of that, and I just want to use matplotlib on it. And there it is. So now you have this unified world of these beautiful views that a geophysicist is used to, or somebody who's used to power plants, their model, but you also immediately, instead of having to export your data and go to a MATLAB or something like that, it's right there. You can use Python, and the full stack of all the things that everybody in this room has built is at your fingertips. It's a really powerful notion. Let me just show one other thing so that you get an idea on the Peephole side of things as well. You end up using a lot of different layers in this in scripting when you have, I mentioned the plug-in notion that we had before. We have the ability to plug in new readers. Customers can write those if they want to. You also have this command line that's always available that people can drag down to and experiment with data. But if you have something like a seismic cube here, I'll pull that in, and we're reading, these things can be terabytes. And so you have to be careful about how you deal with rendering these things. And in fact, what happens is when I move one of these slicers, it's reading it off disk. So it's going out and grabbing that data so that we don't have to have it in memory. But the other thing that we can do is, people often, when you have seismic data, you want to do some attribute calculation. You want to do some math on these things. And so we built in this peephole notion I was mentioning before. It's right here. If I go in and I select one of these things, I now have an algorithm that runs on demand. Whenever I move or load in a new slice, it actually calculates the values on the fly there. And the killer thing about this is that if you go and click on your edit button, that's going to come up over here in Canopy. And you'll notice there's a little UI definition, window length, min cutoff, max cutoff. Those are these values over here. You have your algorithm that you're playing with. And if I go in and edit one of these things, you'll notice down here my min and max cutoff are 1 and 0.5. If I come over here and change one of these and save that out, all of a sudden my UI updates. So you've given this capability to try out a new algorithm, to create a new user interface to your customer, in a very straightforward way. All right? That about covers it. We've got time, we have a few minutes for questions?
Yeah, we have a few minutes for questions. Questions?
Thank you, Eric. So the Canopy is a proprietary technology of Enthought.
Yeah.
Do you see any way for third-party developers to come in and perhaps create, maybe share or sell their applications on your platform?
Absolutely. I mean, the whole point here is to build a layer so that people that are good at algorithms don't have to build infrastructure. And you can provide this common infrastructure layer across geology, geophysics, reservoir engineering, all of those things. And then when somebody sits on top of it, the sum is greater than the parts on that. They can make their application and have it bolt in alongside other ones. So that's it's really the point on this. Thank you.
Any other questions? Okay, let's give a big round of applause for Jones, Eric Jones.